This is Voyager Notes, a transmission from 25 billion kilometers, still transmitting. On the 15th of September 2017, a spacecraft named Cassini entered Saturn's upper atmosphere at 113,000 kilometers per hour and did not come back out. The mission had been transmitting since its launch on the 15th of October 1997. It had crossed 3.5 billion kilometers of interplanetary space, executed a gravity assist, passed Venus twice and Jupiter once, and arrived at Saturn on the 1st of July 2004. By the time of its final orbit, it had returned more than 635 gigabytes of science data. The number is precise because the team counted. Every byte was a decision. What to point the instruments at, how long to dwell, what frequency to use to push the data home through 1.4 billion kilometers of the dark. The grand finale was not an accident or a failure, it was a deliberate act of mission design, and the logic behind it is worth reading carefully. Section 2. Context. Saturn has two moons that concern the people who think about planetary protection. Enceladus, 504 kilometers wide, vents liquid water from a subsurface ocean through fissures at its south pole. Titan, 5,150 kilometers wide, carries a thick nitrogen atmosphere and liquid hydrocarbon lakes on its surface. Both are candidates for environments where biology, if it exists anywhere in the outer solar system, might exist. Cassini was not sterile. It had been launched in 1997, assembled in the years before, and the decontamination standards of that era were not the standards that would apply to a mission explicitly targeting a potentially habitable world. By 2016, the probe had spent 12 years in the Saturn system. Its fuel reserves were running low, and the team faced a choice that every deep space mission eventually faces. What do you do with a spacecraft that can no longer be fully controlled? Linda Spilker, the mission's project scientist, put the dilemma clearly in 2016. If Cassini were left in a decaying orbit, there was a non-trivial probability it would eventually impact Enceladus or Titan. That outcome was not acceptable. The planetary protection protocols were explicit. A spacecraft of unknown biological burden could not be allowed to contaminate a world that might one day tell us whether life arose somewhere other than Earth. The alternative was to use the remaining fuel purposefully, to execute a controlled disposal into Saturn's atmosphere, where the probe would be destroyed completely before it could reach any moon. The team chose the alternative, and in choosing it, they also chose to make the final orbits count. Beginning on the 26th of April 2017, Cassini executed a series of 22 orbital passes that took it through the gap between Saturn's innermost ring and the planet's upper atmosphere. No spacecraft had ever been there. The gap is approximately 2,000 kilometers wide, which sounds generous until the spacecraft in question is moving at speeds that reduce reaction time to fractions of a second. The ring particle environment in that gap was unknown. The team genuinely did not know whether Cassini would survive the first pass. That uncertainty was the point. The data from an unexplored region was worth the risk of losing the probe early. They ran the first pass, the telemetry came back intact, and they ran the next one. Loop hash 1. What exactly did those final 22 orbits find in that gap, and what did the last transmission contain? Section 3. The signal. The gap between Saturn's rings and its atmosphere is not empty. Cassini's instruments detected dust-sized particles of silica, water ice, and complex organic compounds. The density was low enough that the spacecraft survived each pass without shielding damage, but the composition was unexpected. The material in the gap was not simply ring debris settling inward. Some of it appeared to be atmosphere, moving outward. Some of it appeared to be ring particles, moving inward. The two flows were meeting in a zone that had never been observed directly. The mass of Saturn's rings had been a standing question for decades. Estimates from ground-based and early spacecraft observations had ranged across a factor of 3. The grand finale orbits allowed the team to measure the gravitational pull of the rings directly by watching how Cassini's trajectory bent as it passed through the gap. The answer returned in the telemetry over those 22 orbits was 15 quintillion kilograms. That is roughly 40% of the mass of Mimas, Saturn's smallest round moon. It is much less than earlier estimates had assumed. The rings are younger than Saturn itself, probably by several hundred million years. The mechanism that formed them is still debated. Loop hash 2. If the rings are geologically recent, what does that mean for the window in which a spacecraft like Cassini could have arrived to see them at all? Cassini's instruments during the grand finale also measured Saturn's magnetic field with a resolution that the outer orbits could not achieve. What came back was anomalous. Saturn's magnetic field is almost perfectly aligned with its rotation axis, almost perfectly. The departure from perfect alignment is so small that Cassini's magnetometer could not definitively resolve it. For a planet, this is unusual. Magnetic fields on Earth, Jupiter, and every other planet measured are tilted relative to their spin axis by at least a small angle. That tilt is how the dynamo inside the planet reveals itself. Saturn's near-perfect alignment means the internal dynamo is either structured in a way not yet modeled, or there is something inside the planet hiding the signal. Neither explanation was satisfying, and neither was resolved. At minute 7 of this record, something worth stopping on. The instrument that returned the most unexpected data in those final passes was not the magnetometer, and it was not the mass spectrometer. It was the radio science package, measuring atmospheric density. The data showed that Saturn's upper atmosphere rotates at a different rate than the interior. The differential was not small. The upper atmosphere is dragged by the rings above it, rings that are themselves young by planetary standards, orbiting a planet whose interior rotation rate remains one of the genuine unknowns in planetary science. Saturn's day, definitively measured, is still not known. Every estimate carries an error bar. The grand finale narrowed the bar, but did not close it. Payoff of Loop hash 1, the final transmission, the one that crossed 1.4 billion kilometers and arrived at the Deep Space Network on the 15th of September 2017 at 11:55 UTC, contained live atmospheric entry data. Cassini held its antenna toward Earth and kept transmitting as it entered the atmosphere, reporting pressure, temperature, and chemical composition readings from a region no instrument had ever sampled. For 91 seconds, the data came back. The probe's thrusters fired at full power, attempting to hold orientation against the growing atmospheric drag. They could not hold. When the thrusters were overwhelmed, the antenna swept off Earth and the signal stopped. The last data point in the record is a pressure reading from approximately 1,600 kilometers above Saturn's cloud tops. The team at the Jet Propulsion Laboratory knew the probe was already gone before the signal stopped. Light travel time from Saturn that morning was 83 minutes and 20 seconds. By the time the final telemetry arrived, Cassini had been part of Saturn for an hour and 23 minutes. The mission controllers had been watching a ghost. The JPL control room was quiet when the signal cut, not silent but quiet. The mission had been running for 20 years across the full careers of many of the people in that room. Some of them had been graduate students when Cassini launched. The team did not celebrate. They stood, some of them wept, and the building slowly returned to its other business. Loop hash 3. What did the Cassini data do to the models of Saturn that came after, and what has not yet been answered? Anti-decay hook, minute 13. One detail from the grand finale orbits that did not make its way into most coverage of the mission's end. During the final plunge, Cassini's ion and neutral mass spectrometer sampled the atmosphere directly. It found complex organic molecules with masses above 100 atomic mass units in Saturn's upper atmosphere. Not simple methane, not ammonia, large structured carbon compounds of a kind that had not been predicted to exist at those altitudes. The finding was published by Waite et al. In 2018 in Science. Where those molecules came from, whether they drifted down from the rings, whether they form in Saturn's photochemistry, or whether they represent something else, remains an open question in the literature. Section 4. The current state, Cassini no longer exists as a separate object. The probe entered Saturn's atmosphere and was disassembled at the molecular level by temperature and pressure before it reached the cloud layer visible from Earth. Its atoms are Saturn now. That outcome was designed, and the design worked exactly as intended. The data it returned continues to be analyzed. As of 2025, the Cassini archive held by NASA and ESA contains over 600,000 images, and the science output has not plateaued. Papers drawing on grand finale magnetometer data, atmospheric entry mass spectrometry results, and ring gap dust measurements continue to be submitted to journals. The mission formally ended on the 15th of September 2017, but the signal is still being processed. Titan continues to be observed from Earth and by other instruments. The Dragonfly mission, a rotorcraft lander, is scheduled to arrive at Titan in the 2030s. Its target landing zone was partly selected using Cassini radar maps. Enceladus has no approved follow-on mission as of 2025, though proposals have been submitted. The question of its ocean, its chemistry, and its habitability sits in the record waiting for a vehicle and a budget. Payoff of Loop hash 2. The rings youth matters for a reason beyond aesthetics. If the rings formed only a few 100 million years ago, then any observer arriving at Saturn in the 3 or 4 billion years before that would have found a planet without its signature feature. The rings will also not last. Ring material is slowly spiraling inward under the influence of electromagnetic interactions with Saturn's ionosphere. The current loss rate suggests the rings will be gone in another 100 to 300 million years. Cassini arrived during a brief window in geological time when Saturn wore its rings. That window is closing. Section 5. The open question. The large organic molecules Cassini's mass spectrometer found in Saturn's upper atmosphere during the final plunge have not been fully explained. The models built before the grand finale did not predict them. The models built after have proposed ring rain as a delivery mechanism, ultraviolet photochemistry as a synthesis route, and magnetospheric processes as a third possibility. None of the proposals has been tested by a follow-on mission, because there is no follow-on mission currently in transit to Saturn. The magnetometer data from the final orbits narrowed the constraints on Saturn's internal structure without resolving the core question. Why is the magnetic field so symmetrical, and what is the dynamo doing inside a planet whose rotation rate can't be pinned down? The two unknowns are probably connected. The connection is probably sitting in the Cassini archive, waiting for someone to find it. Saturn has no spacecraft around it now. The last probe to orbit it burned in on a Tuesday morning, and the record of what it found in those final 91 seconds is still being read. We sent one spacecraft to Saturn for 13 years. It found a young ring system, an ocean moon, an asymmetric atmosphere, and organic chemistry at altitudes where organic chemistry had no business being. It answered several of the questions it was built to answer. The ones it opened are larger. What is inside Saturn that makes its magnetic field so still? The grand finale transmitted for 91 seconds inside Saturn's atmosphere. Which detail from the record stays with you?
This was Voyager Notes. The signal is still coming back.